The Federal Highway Administration's Mobile Asphalt Technology Center, or MATC, brings hands-on education, technology demonstrations, field pavement evaluations, and asphalt materials and mixture testing straight to the asphalt pavement community. The MATC introduces emerging asphalt technologies into practice, assisting agencies with positive change and promoting innovation within the asphalt industry. There are tools available that have been used in other industries successfully and now have applications in asphalt, specifically the Fourier Transform Infrared Spectroscopy. This technology can help to fingerprint key indicators of asphalt binder composition for use in quality control. The Fourier Transform Infrared Spectroscopy, or FTIR, is a powerful analytical technique that uses infrared radiation to identify and quantify the chemical bonds in a material, providing detailed information about its molecular structure. The FTIR is a promising tool for accurately understanding the composition of paving materials, ensuring that they meet specific performance standards and contain the appropriate additives for enhanced durability and safety. To use the FTIR spectrometer, the technician first carefully places the sample onto the device's sample platform. The spectrometer then directs a beam of infrared radiation through the sample. As the infrared light interacts with the sample, the device measures the specific wavelengths of light absorbed by the material. This process produces a unique spectrum, a graphical representation of the material's infrared absorption at various wavelengths. The spectrum acts as a chemical fingerprint, revealing the composition of the sample in intricate detail. The resulting spectrum displays a series of absorption peaks, each corresponding to different chemical bonds within the sample. These peaks are analyzed to identify and quantify various components, such as lime, polymers, and potential contaminants. By interpreting these peaks, technicians can determine the precise chemical structure and composition of the paving material. For example, a sharp peak at a specific wavelength might indicate the presence of a polymer additive, while water in the sample can introduce broad peaks, particularly in the OH stretching region, around 3,400 centimeters to the -1, which may obscure other significant peaks. Additionally, certain minerals within the aggregate might have distinct absorption features that complicate spectrum interpretation. Ensuring the sample is dry and understanding the mineral composition is crucial for accurate analysis. This level of detail is crucial for ensuring that the materials meet the required specifications for performance and durability. By providing a clear and detailed analysis, FTIR spectroscopy enables technicians to make informed decisions about the quality and suitability of paving materials, ultimately leading to safer and longer-lasting road surfaces. Combining the FTIR with other technologies allows technicians to comprehensively assess both the chemical and elemental makeup of paving materials, ensuring quality and safety in asphalt production and maintenance. To learn more about the FTIR and other testing activities being demonstrated by the MATC, visit our website at fhwa.dot.gov/MATC.
Learn more at www.fhwa.dot.gov. Follow the Federal Highway Administration on Facebook, Instagram, Flickr, LinkedIn, Twitter, and YouTube. The U.S. government does not endorse products or manufacturers. Trademarks or manufacturers' names appear in this video because they are considered essential to the objective of the video. They are included for informational purposes only and are not intended to reflect a preference, approval, or endorsement of any one product or entity. Except for any statutes and regulations cited, the contents of this video do not have the force and effect of law and are not meant to bind the public in any way. This video is intended only to provide information to the public regarding existing requirements under the law or agency's policies.